This is StarTalk, Cosmic Queries Edition, Grab Bag. Chuck, that's your favorite category, isn't it?
Gotta love the grab bag, man. All kinds of good stuff all up in the grab bag.
You just
People
reach,
come at us with whatever they want.
you put your hand in, you don't know what you're going to pull out, and there it is.
That's right.
All right, let's get right to it.
It's StarTalk bingo.
And it's all Patreon members. $5 a month gets you access. All right.
Best deal in town.
Waste no time.
No time. We're jumping right into it. Kate from Warsaw, Poland says, hello, Dr. Tyson. Hello, Lord Nice. Lately, I've been wondering about the Fermi Paradox. Do you think it could be possible we have found no advanced civilizations or have not been found because of the speed of light? Could they just be too far away? Or could it be that they have done to their planets what we are currently doing to ours, and they're just all dead?
Okay. All right. So let me remind people about the Fermi Paradox. Enrico Fermi, he was an Italian-American physicist, in 20th century physicist, brilliant guy. And he did an actual calculation on the back of an envelope, as we call it. So it wasn't some grand chalkboard calculation, just he made some estimates. And he said, all right, I know the speed of light is fast, but let's say they have a civilization that can go maybe 1/5 the speed of light, some fraction of this, 10% the speed of light. I'm not, is that asking too much? All right.
Not too much.
That's not too much. All right. Let's say 10% the speed of light. How long would it take you to cross the galaxy? The galaxy is 100,000 light years across. So if you go 10% the speed of light, it'll take you 10 times that. So it'll take you 1,000,000 years. All right. Okay. That sounds long, but hang on a minute. That's not where you're first going to go. You're going to go from our star system to the nearby star system.
Okay.
Okay? And then you're going to pitch tent, grow civilization, and now you're going to launch again. And then, but now you're not just going to go to one more, you're going to go to two more. Okay?
Okay.
And then each of those two will go to two more each. So that goes to 4, to 8, to 16. And so your civilization spreads out rapidly, exponentially. All right? And you'll get to nearby stars in 10, 20, 30, 50 years. All right? And you just have a new civilization there, and they send out two more probes. What he concluded was, if any sensible assumptions you make, the whole galaxy and all available planets can be colonized within a few million years.
Okay.
That is short compared with the lifetime of the galaxy. So if it's nothing. So we're Johnny-come-latelys here. Suppose you had an advanced civilization that started 5 billion years ago at the birth of the sun, a whole other star that's been around. All right? Then they could be all over the galaxy, and we don't see them. Where are they? Okay. So then everyone is saying, well, how come we don't see them? Yes, one of the reasons are they could be just like us and destroy their own planet. Okay? They're so smart, they figured out how to destroy themselves. That's one example. Another one is space travel is just too hard. It's just hard. You can move around to your moon.
They're stupid.
God,
this is hard.
Well, no one told us it'd be so
Why
hard.
did it have to be so hard? God, we keep trying to go to space, and we can't. It's just too hard, okay? So crazy.
Weeping aliens across the galaxy.
Exactly.
They can't do it. So, all right. So that's what one of the reasons. Another one. This is my favorite of them. Is that whatever genetic profile, whether or not they use genes, whatever is in you that wants you to colonize planets, if that's driving your entire civilization, and you go this way, and you get 2 planets, and you get 2 planets, there'll come a time where we both want the same planet.
Exactly.
Ooh.
Why do they have? Why is their planet so much nicer than our planet? We all started at the same time. I don't understand it. Why is their planet so much better? You know what we should do? I'm just saying, guys, what we should do We should go over there and take that planet. We should take that planet. Okay? Now, wait a minute.
That's colonization in a nutshell.
Yeah, there you go. Now, listen. Just because we're on planet Caucasoid and they're on planet Negro doesn't mean that we're doing it just because of that.
All right. So, if that's the case, then the whole system will implode, which kind of happened with European colonists. All right, England had colonies, France had colonies, Spain had colonies, Portugal had colonies, the Dutch had colonies, and you reach a point where there's not enough land to go around, and they fight each other for control of that land. Okay, right. So we saw that play out on Earth's surface, where if you have this expansionist mentality. So it could be that whatever is the urge that would want to make that happen in the first place has the seeds of its own unraveling.
Wow. So the curiosity that brings you to want to branch out,
yeah,
and the drive, more important,
yes,
is the thing that is your undoing,
yeah,
because that same drive caused you to lust for the very things that you want to achieve in others. I'm the only person that can have this.
Right.
I want to do this.
And I wouldn't call it curiosity so much as hegemony.
Ooh, yeah, great word.
Good SAT word.
Ooh, I like it.
Are you hegemonous? Yeah, just the need to conquer and to control. This is a thing. But there's a third category, fourth. I lost track. This is my favorite. You ready?
Go ahead.
They have come to Earth, and they tried to visit, and they saw all of the space debris orbiting Earth, and they said, no.
They were like, that's Sanford and Son planet. That's the Sanford and Son planet.
Oh, you're saying those aliens are black? They say,
Look at all that junk in their front yard. Nobody would have come see this. Why would we want to go there?
So there's that. Well, I got another one, right? So I take full credit for this one. They have visited, but they accidentally landed during Comic-Con.
Okay.
So nobody noticed.
That is so silly, but it's so funny. They're like, listen, we kept saying, take me to your leader. People would laugh at us and go, good one, and love the costume, and then they would walk away from us. What's wrong with these people?
What's up with that?
Yeah.
So I think that one, I that's the most fun one for me to think about, I think. Or they, rather than destroy us, which is every movie wants them to do, they phoned home and said, on Earth, they're just like us.
Right.
From the Comic-Con experience.
Could be.
Nothing interesting.
Nothing to see here.
Yeah, so those are the prevailing, there might be others, those are the ones I carry with me for solutions to the Fermi Paradox, why they're not here. Yeah.
Awesome. All right, let's go to Omar Marcellino. And Omar says, hello, Dr. Tyson and Chuck. Omar here, originally from the Boogie Down Bronx.
Oh, Bronx in the house.
Living in Texas now. My son Roman, who is 7, wants to know this from you, Dr. Tyson. If you had a chance to see only one, would you rather see dinosaurs live and roaming the planet or aliens?
So I'm going to have to pick aliens, only because, even though I love me some dinosaurs, we already have pretty good representations of them in movies. We got their fossil bones. We've got good archaeological evidence. And so I'm aliens, totally. Aliens.
Yeah, that definitely.
And if it asked me to take it to our leader, I ain't taking it to the White House. I'm sorry. I'm gonna go. I might go to Washington, where the National Academy of Sciences meets, and bring him to a meeting. Yeah,
I would take him to Beyonce.
That'll mess with his head. I don't know. All right. Next
Very
question.
Cool. This is Brendan Gambassi, or Gambushe. He gave me
helping you out.
Phonetic spelling.
Helping you out. Okay.
Helping me out. Gambushe from Lansing, Michigan. He says,
You can't
"Hello,
pronounce.
Doctor."
You can't pronounce
I
Michigan.
can't say Michigan.
You got the guy's name.
I got the guy's name finally right, and then I messed up the state. Isn't that something?
Okay.
Michigan.
Michigan. All right. Go.
Okay. He says, "Hello, Dr. Tyson. I am interested in knowing what your favorite astronomical discovery of all time is. And Lord Nice, what is your favorite thing that you've learned on StarTalk?"
Good one. I love that. I love it.
That's hilarious.
I love it. So my favorite is the fact that the discovery that all life on Earth and Earth itself, owes its chemical origins to stars that have exploded after having manufactured them in its core. That exploded, scattering that enrichment across the galaxy, reaching pristine gas clouds that would form a next generation of stars and planets, one of which was ours. That discovery was in 1957 in a research paper by 4 authors. One of them is a couple that were married, Burbage, Fowler, and Hoyle. And that is basically the origin of the elements. It's a spiritual gift of modern astrophysics to civilization, for us to now be able to tell you we are not just figuratively so, we are literally stardust.
Wow.
And not only that, as we are alive in this universe, because we contain stardust, the universe is alive within us.
Ooh.
That is my favorite astronomical discovery.
Nice.
All right. So, Chuck, what's your favorite thing you've learned?
Oh, what I just learned right there. That'll do. That'll do just fine. No, everything is my favorite thing that I've learned.
Really?
Oh, God, yes. I tell people all the time that my job is to take a master class in astrophysics with the world's foremost science communicator, and like who could have a better job than that?
Whoa!
Like, that's amazing.
Okay, so
right?
you want a diploma or something? You're fucking for a certificate of completion.
Right, and it'd be kind of cool if I could get a little certificate. Just Chuck is not as stupid as you think. That's what my certificate would say.
Okay.
Very cool.
All right, we got to take a break. We got to take a quick break. When we come back, more StarTalk Cosmic Queries, Grab Bag Edition, when we return. All right, Chuck, let's keep this going. Keep the party going.
Keep the ball of wax rolling. Here we go. This is Matt Berg. He says,
wait.
Greetings.
Keep the ball of wax rolling? What?
Yeah.
What balls of wax roll? What does that come from?
I don't know.
What is that?
It's just something that comedians used to say when they were MC shows. All right, guys, let's keep this ball of wax rolling.
Wax, that's not a thing that wax does. No balls.
If you put it in a ball, it does.
Okay. Well, then any ball would roll. I mean, it just have to be wax.
There you go.
Okay, fine. Go on.
All right. This is Matt Berg. He says, greetings, Dr. Tyson, Lord Nice. Matt Berg here from Sheboygan Falls Middle School in Wisconsin.
Middle school.
Yes, sir, buddy. He says, one of the main concepts we discuss in my middle school class is the importance of basing final conclusions on scientific evidence that is gathered. A student and I were talking about the expansion of the universe, and she asked that if the universe is expanding faster than the speed of light, doesn't that, in essence, make part of the universe essentially inaccessible, just as our seeing inside a black hole is impossible, thereby prohibiting us from ever gathering the needed information to make a final conclusion, especially back to the original singularity. If I understand this correctly, and this is indeed true, the fact that we are losing access to the evidence makes me feel very, very uneasy. Could you please make me feel better by telling me that I'm wrong? Help!
Chuck, what's... We don't know he had all that emotion at the end of the letter.
I took a little liberty. A poetic license.
By the way, 3/4 of the way through that, we did not know whether that person was a student or a teacher.
No, we didn't.
We didn't. I said, damn, if a middle school student is asking this.
Yeah, if a middle school student was asking that.
Right. Okay.
Yeah.
So, everything, tell me the person's name again.
This is Matt Berg. Matt Berg.
Yeah, Matt, everything Matt says is correct. Next question.
There you go, Matt. Sorry.
Yeah, we are losing the universe as it expands beyond our horizon.
Damn.
And in the limit, if the acceleration of the expansion continues, then every single galaxy in the night sky will expand beyond our visible horizon, leaving our galaxy and the stars within it alone in our own observable universe.
Look at that.
Yeah, so
an island galaxy.
An island galaxy, and as far as we would know, an island universe. Why would there be anything else? In fact, that's what we used to think. We used to think all the galaxies were just fuzzy little things within the Milky Way. And Hubble says, whoa, these fuzzy things are flying away. They can't be within our own galaxy. They're other galaxies. So, if the day that comes where all the galaxies have expanded beyond our horizon, we will return to what we thought the universe was like before Hubble. Just our own galaxy, and that's it. So, yeah, it's where the galaxy is thinning out. Get over it.
Look at that. Just like your hair, Matt.
No, stop. Would you?
These are just the harsh realities of life, my friend.
All right.
All right. This is Jesse McIntyre. And Jesse says, hey, Nunchuck and Dr. Tyson.
He called you Nunchuck?
He called me Nunchuck.
Nunchuck. All right.
I guess I'm got to get ready to get flung around by Bruce Lee.
Yeah, you're a martial arts weapon. Yeah, all right.
Yes. This is Jesse the Farmer from Duval, Washington here regarding quantum entanglement. If information is instantaneous, regardless of distance, is the bridge between the two particles possibly an Einstein-Rosen bridge? Well, anyway, love the show and get learned.
Yes.
Boom. There you go.
And just to bring closure to that, I think I mentioned this in another episode. I was having lunch with Brian Greene, and author of The Elegant Universe and several other books that followed that. And he's a brilliant educator, co-founder with his wife of the World Science Festival held annually in New York. And so what he told me was in the vacuum of space, we've known that there are these things called virtual particles, because quantum physics says you can't have zero energy anywhere, that there's fluctuations in the space-time fabric, quantum fluctuations that will always give you a little bit of energy. You'll never be pure zero. There are people who want to tap that vacuum energy and propel themselves with it. We don't know how to do that yet, or if ever. But point is, these virtual particles pop in and out of existence from that energy, equals mc squared. Then they come back together again. Okay? So, when they pop into existence, they are quantum entangled. And then they return no longer quantum entangled. There's been some thinking lately to suggest that these two quantum entangled particles are connected by a wormhole, such as the EP bridge that he mentioned. That's a wormhole.
Right.
Okay?
Right.
It's just a fancier name for a wormhole.
Fancier name for a wormhole.
So if that's the case, and these particles are happening everywhere, it may be that wormholes are themselves the fabric that stitches the space-time continuum.
Oh, look at that.
That the wormholes that connect entangled particles is the medium of the space-time continuum. And that's a profound new thought. That's my new thought for the month. Yes.
That's amazing.
Yes.
That's crazy, by the way.
Crazy. It's crazy.
It's crazy.
Well, it had to be stitched somehow. Somebody's got to do the stitching.
It's true,
and
right?
It's the wormholes. Mm-hmm.
Amazing.
There you go.
That is fantastic.
Yeah.
Oh, I'm so glad you asked that question, Jesse McIntyre.
All right. Farmer, what kind of farmer is Washington? Is growing apples or grapes? one or the other.
True. Some.
How's that for stereotype?
Very good Pinots, right?
Yes, Oregon
Washington Pinots.
Yeah, and Chardonnay.
Yeah.
It can
Chardonnay as
happen.
well. Yeah, very cool. All right. This is Colin Brum. And Colin says, my first query ever, guys. He says, this one's kind of been gnawing at me regarding black holes. How can matter fall into the singularity or even past the event horizon at all? If someone approaching the event horizon would see for the first time the rest of the universe speed up infinitely, and black holes don't last for an infinite time due to Hawking radiation, shouldn't any matter falling towards the event horizon either be instantly turned into Hawking radiation in its own time frame, or simply ride the event horizon down as the black hole evaporates away? Neither one of these would allow you to go to the singularity, which is something physics can't currently explain anyway. Love listening to you guys. Keep up with this incredible show.
And who asked this question?
This is Colin Brum.
Okay, Colin Brum. Chuck gave you attitude for the end of that question. Which physics can't explain. Anyway.
Well, I see these kind of like comments sometimes where people.
I'm just saying, nobody gave you permission to give attitude to the questions.
I know a lot of people think that the singularity is a BS concept.
We don't know.
They think it's cheating.
No,
they think it's cheating.
No, it's the edge of Einstein's general theory of relativity, and we need another theory to extend it. So so it's not cheating. It's our ignorance.
There you go. Right.
We're very candid about it. All right. Here's the thing.
I love that. Right. You can be ignorant of something and go to the edge of knowledge, but then you just say, "I'm at the edge of knowledge."
Yes.
We need something else here now, because if we step over this line, stuff does not work out anymore.
Yeah.
So we need something else. I think that's brilliant. That's one of the things I love most about every time we do this show.
And it's occasionally said that the singularity of a black hole is where God divided by zero. All right. Remember, you're not supposed to divide by zero.
You can't divide by zero.
Can't divide by zero.
Don't do that.
No. So, here's the thing: if you fall towards a black hole, you're just going to fall in.
Right.
You don't stop anywhere. You just keep going. If we try to watch you fall in, that's a different story. Okay? So, but you and your time frame, time is ticking just like normal for you. So, no, you're not held up. But as you cross the event horizon and you go down towards the center of the black hole, you will see the entire future history of the universe unfold before you.
Right.
And if you don't come out the other side, an interesting question is there. You will get Hawking radiated while you're watching the future history of the universe play out.
Right.
That can't be comfortable. I don't know what's worse, the spaghettification falling in or the Hawking radiation atom by atom as you come out. Yeah.
Right. So it's all about frame of reference.
Yes.
It's all about frame of reference.
Yes.
So
you got it.
If you try to look at it like you're not without the frame of reference, then you're screwing the whole thing.
Right, exactly. You're cross-combining frames of reference, and you can't do that. It doesn't work out. Right. You don't get a coherent understanding of what's going on.
There you go.
Right. Okay.
That's fantastic. All right, here we go now. This is Dre Adamenko. He says, a mirror shows a reflection of whatever is in front of it. What does it reflect if we put a second identical mirror directly in front of it with 100% precision? We've all seen the infinite tunnel of mirrors in the public bathrooms when they're facing each other, but it's impossible to look directly at the center because the object or the person is in the way. What would we see at the center? Darkness? A void? A parallel universe? This is really bending my mind, man.
Okay, who asked this again?
This is Dre Adamenko.
Dre, if you manage to do this, it will create a rip in the space-time fabric of the universe. So I don't recommend it.
You will destroy us all, Dre. That's what will happen.
So what would be this? So let me just think this through. I haven't thought about this before. So if they're exactly front and back, there'll be some light that comes in from the side, but that'll reflect off to the other side, okay? And it won't go in line with the mirrors. If they're exactly facing each other, and there's no light in that path, then it should just be completely dark with nothing to reflect, ruining your funhouse mirror phenomenon. It would just go dark. Yeah. As it already is, if you look at the multiple mirror reflections, the farther in the mirror you see, the dimmer it gets.
The dimmer it gets, that's right.
That's correct, because it has less light to
reflect back and forth.
All that many times. So it gets darker and darker and darker. But in this case, there's no reason why it wouldn't just be dark right off the top, because there's no light there.
There you go.
Now, I've never done the experiment, but using my knowledge of reflections and physics, that would be my answer.
Super cool.
Yeah.
Yeah. It'd be cool to see,
So what you might do is get a two-way mirror, okay, and then put a laser through, when it comes through, and you'll still get a reflection. See what happens. I don't know.
Okay, there you go. So there's your homework. Okay, Trey? Got a little homework to do, buddy.
Yeah.
All right, here we go. This is Piotr Tornuski.
Okay.
Torunsky. Think so. Okay. And it's Piotr from Poland. So maybe that's Polish way of saying Peter. I'm not sure.
Okay.
I'm gonna call you Peter, boy.
All
okay.
Right. Okay.
He says, "Hey, Dr. Tyson, what's up, Chuck? My question concerns the shape of the universe. If we know that the universe is ever expanding, does that mean it has an edge? If the Big Bang happened in all places at once, does maybe then the universe keep expanding more like a ball, so without a clear edge? If so, would that ball be in some higher dimension? Thanks, and love the show, Peter, or Piotr from Poland."
Yeah. So Piotr is Polish for Peter, right?
It is.
Yeah,
okay.
I'm pretty sure of that. Right. All right. So excellent question. So first of all, the universe, when we speak of its size, it's to our horizon. Now, that edge is today farther away than that, because it's been expanding for 14 billion years since then. Okay, so if you look at the actual diameter of the full universe, it's not an observable diameter, but you can calculate it. Last I checked, it was something like 92, 94 billion miles in diameter, right? The universe today. Beyond the horizon, there's no reason to think there isn't more universe.
More universe.
Yeah, just like a ship at sea. There's probably more ocean just beyond your horizon, okay? Right. Eventually you hit land, great, but until then, you're not saying all I can see is the entire ocean. No one is saying that. All right.
Right.
So now the question was, what's outside of that? The expansion? Well, we don't know for sure, but the multiverse, which is what you get for free when you bring quantum physics to general relativity and Einstein, you get a multiverse that's pumping out universes. And there are different levels of multiverse, but the simplest is that it's outside of our horizon. There are other bubbles of universes. So that doesn't require a higher dimension to embed them. It's just imagine, how would you do this? A big expanding rubber sheet, but you have these circles that you draw, and each circle, in that circle is an expanding circle. That's a universe. And then another universe over here. So the space-time would enclose multiple universes that are expanding. That can happen too. But there are higher-level multiverses that require embedding in higher dimensions. And you can do that. You can have infinite universes that don't overlap.
Right.
You know how to do that? Did I tell you how to do that?
You watch Rick and Morty?
Yes, that's how you do that. No. So let's take it down a few dimensions. So let's say the universe is a flat sheet of paper. Okay. 2 dimensions instead of 3 spatial dimensions. Make that sheet of paper infinitely large. Okay. Right. Now take another sheet of paper, put it above it, and make that infinitely large. We have two infinite sheets of paper that do not intersect.
Right.
They don't touch each other. So
They never touch.
Because they're embedded in a higher dimension. They're two-dimensional objects.
They are literally parallel universes.
Oh, there you go. So we take our universe and embed it in a higher dimension. We could be infinite, sitting right next to another infinite universe, and never the twain would meet. That being said, there are people who are looking for universes that go bump in the night. Is there a signature in our universe in this direction that looks a little different from this direction? Is this bruised in any way? All right. Did we get knocked by another universe passing by? There are people who have looked. They haven't found any anomalous features in the edge of our signatures. So
super cool.
Yeah.
God, you just gotta love this stuff, man. What the hell is wrong with people? How could you not love this? Okay, this is Zach Stein. He says, hello, this is Zach. I'm a first-time caller from Kentucky.
First-time caller. Yes, okay.
Long-time listener, first-time caller. Okay. He says, how does scale pertain to the multiverse and quantum theory? If the rules of physics could change in a different universe, could this be factored into changes in scale? We already see this in quantum mechanics. Could the same thing happen as we move up in scale in any other direction?
Okay, so scale, I don't know if I fully understand the question, but I can tell you this. When we figured out planets going around stars, we said, that's cool, okay. Then we would later learn about atoms that have electrons. And they say, well, we've been down that road before. We got planets going around stars, electrons going around nucleus. So is it that all the way down? Is it that all the way up? Is it just things orbiting other things? Turns out, no, it's not. It's very, very different. That's why we don't say electrons orbit. We say they move in orbitals. We borrowed the word and added an AL at the end. So electrons exist in orbitals, not orbits. So it's not scalable in that sense. It's just not just a big version of something little or a little version of something big. Plus, there are other issues, right? So Chuck, if you had to scratch your head because you got a head itch, show me how you would do that. Just do it. Okay, there it is. Scratch your head. Okay. Well, you did that like a monkey does it, you know. Yeah, that's how monkeys scratch.
Pinky finger. I thought I was being dainty.
Okay. Do you have lice? Just let me know, because that's what the... So, you have an itch in your head, and you responded within a fraction of a second, okay?
Right.
If things just scaled, and you were the size of a galaxy, and just make it bigger. If you were the size of a galaxy, and your head itched... You'd have to send the signal from your head to your brain, to your fingertip, and then move your fingertip to scratch your head. Okay?
Right.
That can't happen any faster than the speed of light. So the galaxy is 100,000 light years across. So the signal to get to your fingertip and then come back and scratch your head would take 200,000 years to scratch your head.
Right.
That's not particularly helpful if you got an itch.
Yeah. It's not very efficient.
Right. So we're thinking big creatures that if they existed, itching is not a thing. Okay? So my point is things just don't scale the way you might want them to. Otherwise, it would make for a very easy nesting doll universe, all the way down and all the way up. So that being said, it is possible for other universes to have slightly different laws of physics. Yes. That is possible. And that would change everything. And if you come upon such a universe, do not knock on its door. Send in something else, okay? Send in a gerbil or something. I don't know. Nobody likes rats. Send in a rat and find out what happens to the rat. All right? If it collapses into a pile of goo or explodes with its guts all over, or it comes back with 3 eyeballs, I don't know. Depending on the laws of physics, very many things can be different.
Wow.
Yeah.
Well, there you go. That's very
and
cool.
By the way, in the Cosmic Queries book, Okay, that's one of the installments of the StarTalk book series in collaboration with National Geographic. In that book, there's an entire chapter. There's an entire chapter on how the universe will die. And it has all the ways. And it describes how the multiverse gives us all these different combinations of size, laws of physics, and the like. So it's a fun read. So check it out.
Very cool.
Yeah.
Very cool.
Mm-hmm.
All right, let's go to Renee Skirp. Renee says, hello. Hypothetically speaking, could you walk on the rings of Saturn? Again, hypothetically. If you were to land on Jupiter or a gas giant, would you just fall straight to the core? Can't wait to hear the answer. Thanks, Renee.
All right, so here's what will happen. Saturn's rings are not a thing. There's just like countless particles orbiting Saturn. Okay, so you can't take your car and drive on Saturn's rings like it's a racetrack. Okay, and it's not a surface. And all the gravity points towards Jupiter. So no, you cannot walk on, not even hypothetically, can you walk on Saturn's rings. Now,
Not even hypothetically.
not even
Dang.
hypothetically. Sorry about that. So
disappointing.
So now you want to land on Jupiter or Saturn. You get to the outer surface, but it's gaseous, and you keep falling, and you keep falling, and you keep falling until you and the surrounding gases have the same density.
Right.
Then you'll just float there.
Oh, just like you're in water.
Yeah. You finally you'll get to a place under pressure where you'll just be buoyant there.
You're buoyant. Yeah, you can't go. Yeah, when the little bit of scuba diving I've done, if you want to get to a certain depth, you have to wear weights.
Add weights.
Gotta have weights.
Exactly.
Just for that reason.
You scuba dived before?
Oh, yeah.
Oh,
yeah.
wow. Cool.
Yeah, I enjoy it immensely.
Okay, what's scuba stand for?
Oh, God, you would do this
Dude,
to me.
Whose show are you
I
on?
know it's an acronym.
Dude,
Hold on. Oh, God, no. You got me, man. Wait.
No.
Crap. I can't remember.
Self-contained, underwater...
Breathing apparatus.
Yes, there you go.
Doggone it.
Man.
Got me.
Okay.
Got me.
Just to atone, what does laser stand for?
Oh, man. I can't believe it.
I'm just trying to help. I'm trying to give you just save face here.
Okay.
Light amplification.
Amplified, stimulated emission. Wait, what's the R? Stimulated emission. What's the R? Damn it. I'm losing my mind.
Yeah, light amplification by the stimulated emission of radiation.
Radiation. Yeah. Okay, I should have known that.
All right, you're 0 for 2. You need one out of here. Okay. What does AM stand for? As in AM and PM. AM.
AM stands for staticky radio.
No. Okay, you win. Okay, we'll let you out of that one. I'm trying to help you out here. AM and PM. Yeah. You know what AM stands for? AM and
I
PM.
don't really know. I'm terrible.
You use it every day. AM and PM.
I know. I do.
Okay.
So after midnight and I don't know, post morning. I don't know.
Maybe we'll do one with abbreviations. We'll do an explainer one day with abbreviations.
We should, because let me tell you something.
Out.
I use all this stuff, and here's the problem: I read these things, and then I just forget. It's why? Because you never say them.
No, but plus you need context to understand. Once I teach you AM and PM, you'll never forget it. I promise.
Okay.
Right. So we'll do it.
I'm not going to look it up, and I don't do Google. When I don't know something, I don't do the whole let me run to Google. I'm like, okay, I got to look it up and I got to read it.
Yeah.
But like laser, I'll read that a million times and I still won't remember.
Okay.
So, and scuba, when I first scuba dived, I had to, of course, look up.
Mm-hmm.
That's the first thing they make you learn.
Yeah.
before you ever put the tank on and go into the pool, which is where you learn is the pool. But yeah, you got to learn. So.
All right.
But I'm interested for AMP, and I'm not going to look it up. So.
Yeah, the AM, PM, there's AM and FM, XM.
AM, right.
XM radio.
Okay.
Those all stand for things. So.
All right, let's do it. We'll do that explainer.
Okay.
That'll be fun. That's a fun one.
So did I finish answering that question?
Yeah, you did, because basically the answer is no. You can't walk on the rings of Saturn. And
and you'll sink until you're buoyant.
You cannot fall to the center
buoyant.
of a gas giant. You're going to, at some point, reach a place of buoyancy.
Correct.
You're going to be stuck there.
And there is a place we think Jupiter has a solid core, very far down, or one of them.
But you'll be crushed before you get there.
What was it, a solid core or a sex? Yeah, you're long dead before that happens.
You're long dead before you ever reach it.
Is it a solid? There's like an Earth mass of solid stuff in the center of Jupiter.
Oh.
Yeah.
Oh, I did not know that.
Yeah. Okay.
Yeah, Jupiter's that big that inside it's pregnant with a little Earth.
That's
awesome.
Yeah.
That's awesome.
It's a Tootsie Roll middle.
Yeah, Tootsie Pop.
Last question,
great.
one more, real quick.
All right, here we go. This is Bruce Ryan. Bruce Ryan says this. What's up, gents? Bruce Ryan here from Alexandria, Virginia. Suppose there was a small black hole with an event horizon the size of a basketball floating in front of you. What would happen if you put your hand through that event horizon? Would it suck your entire body through? Or would you just lose your hand or something?
Ooh.
Kind of wild in a way. I like that question. Yeah.
Ooh. I don't know if it'll just bite off your hand or if you'll fall into it. What I do know is that if you let go of it, okay? By the way, that basketball-sized black hole would have more mass than the entire Earth. So what would really happen is you'll fall in. You'll just fall in, okay? Because its gravity will just pull you in.
Its gravity is, right.
It'll just, you can't not fall in it. But because it has more gravity than Earth does, if you let it go, it and Earth would fall towards each other and Earth would lose. It would eat the entire Earth systematically. Wow. Yes. It'll break apart Earth and just chew it and burp, and that's it.
Ooh, I'm telling you right now, this Earth, child, this Earth is delicious. I don't know who set out for Earth, but I'm telling you right now, you need to call Uber Eats and get some of this Earth. Saturn, have you had this Earth?
Actually, the black hole wouldn't have to lick its fingers because it is all going straight down the hole.
It's just going straight down the hole.
It's just going straight down the hole. No finger. It's not even finger licking good. It's like swallow good. That's what that is.
There you go.
Well, that's all the time we got, Chuck. Oh man,
that was fun. That was a lot of fun.
Yeah, grab bag that was. All right, always good to have you here. Right there,
always
checking this out. This is StarTalk, Cosmic Queries Grab Bag Edition. Neil deGrasse Tyson. Keep looking up.